Welcome Math 30-2, and now we're going to be focusing on fractions at first, and then we're going to go in rational expressions where they have the same denominators, and when they have the same denominators, basically we just have to follow the operation with adding or subtracting. So let's get on it. Class example 1 on page 440, we're going to be looking at 5/9 minus 2/9. Both have the same denominator, so just follow the instructions by doing 5 minus 2/9, and that finishes off by doing 3/9. And of course, you could simplify that one more step further because they're both in the 3 times table, 1/3. Next one, 2/3 plus 2/5. In this case, they have different common, they're not common in denominators, so make them common in denominators by making them 15. So what did I do here? You times that by 5, so that must make the top to be 10. And then the next fraction, I times that by 3 to make 15. So 2 times 3 is 6. So 16/15 is our final answer. Moving on to the next one, 5/6 minus 1/4. Both of those are the lowest common denominators, 24. Keep in mind, a rule of thumb, if you can't figure out what the lowest common denominator is, that both could fit in there, because in reality, 12 is the lowest common denominator for that. You could just do 6 times 4 to make that easier for yourself. So here's your 12. How did I do that? 6 times 2. So 5 times 2 is 10. How did I do this one? 4 times 3. So 1 times 3 is 3. So 7/12 is our final answer. Okay, moving on to the next one, you are going to be realizing now we're going to start throwing in some variables. No difference, collect like terms. If you collect like terms correctly, you shouldn't have a problem if the common denominator is there. Hence the fact there is. So 2x minus x over 3. So now, how many x's do we have left? If you take one away from that, just an x. So x over 3 is our final answer. No worries about finding NPVs here because their bottom has no variable. Keep that in mind. So looking at the next one, 3x over 4 plus x over 4. So plus x over 4. Collect like terms like normally. So we're going to end up with 4x over 4. And there is one more step here. Can we simplify that? Yes, we can take out a 4 from the top and the bottom. And what's going to end up happening if we do that? We're going to cross that out, and we're left over with just x. Over here, now we have binomials with a monomial. So binomial meaning 2, that's where that's coming from. So what's going to happen in this case is they're both over 5. Okay, so just collect the terms. So that means minus 3 plus 9a plus 1. Collect all the a's, collect all the constants, and what's going to end up happening here, 2 plus 9 is 11a. And then what happens with negative 3 plus 1? So you're still in the negative, minus 2 over 5. And there is no need to worry about anything else from there because of the fact that there is no actual common, you can't cross out a binomial with a monomial. So that's another thing to consider. So with D over here, what's going to happen here is that they're over 6. Okay, so do the same thing as earlier. 5y minus 1. Be careful for this step. This negative means is applied to both of that binomial because it's one collected in there. So I'm just going to rewrite it as, what it should be, plus, oh, my apologies here, minus 4y minus 7. So this is saying negative 1 times 4y, negative 1 times 7. Hence the fact you get the following. Okay, that's all over 6. Let's move the 6 more in the middle, looks more neat. Okay, 5y minus 4y makes the negative 9y. And that leaves us with now this negative 1 with negative 7, negative 8. All over 6. Can we simplify? Sorry about this. I made an error for this question. The first step was fine, where it actually expanded the whole fact of putting this negative here. The second part is fine too, where I put the negative with the 4y and the 7. But the error was this, 5y minus 4y. I put 9y on the original whiteboard, but it should actually just be y. y minus 8 over 6. Now, going on example 3a, now we're dealing with not the same common denominator, so you have to figure out the common denominator in that case. So when you're dealing with this part, first thing, find the common denominator. 20 would be the common denominator in this case. So what's going to happen is that, I'm going to put 20 here. 4 times 5 makes the following. So 5 times 3x is 15x. Now, how did I get from 10 to 20? I multiplied by 2. So that would mean 7x times 2 is 14x. What happens from here now? You could just collect like normal terms. You just get x over 20. There is no need to find the NPV because the denominator is still a constant. So moving on to over here, the 6 would be the common denominator in this one. So right off the back, there's your 6. 3a minus 1, I have to times this by 2 to make that happen. So that'll be 6a minus 2. 3a times 2 minus 1 times 2. That's where that's coming from. And then 4a plus 5 stays the same. Okay, so now from here, collect the like terms. The 6a and the 4a are the like terms here. So you become 10a. And then minus 2 plus 5, you're getting rid of the minus 2 with the 5, and that would be positive 3 over 6. Can we simplify any further here? Well, it doesn't look like there's anything common with the 10 and the 3, so no. The 6 would be nice to cancel something out, but you can't. So what our answer would be in the end here, let me just move my board a little bit to the side. Doesn't look like it's going to work. Let's move it here. There we go. 10a. 10a plus 3 over 6 is our final answer then. Okay, with that in a shell, now we can move on to class example 3c. In that case, what's going to happen, class example 3c, let me just erase this quickly here. 3c, we're doing the same thing as we did down here, find the common denominator. Now, keep in mind, finding common denominator, some students find it easier to actually just, multiply both the denominators with the same alike, and that works too. The only downside with that is you're going to have times where it's a very big number, where a calculator would be very helpful to have. But not everyone likes to use a calculator right away. But I could see where the situation for that would be. Okay, with that in place, what's going to happen here? 8 and 3, if we take 24, because 8 times 3 makes the 24, you could go with that. Okay, so how did I go from 8 to 24? Times it by 3, so I have to times this by 3. So that makes 24y. Times 3 with this one too, because we did the same thing with that one. So that'll be negative 9. That negative now, keep in mind to apply to the whole thing. I have to times this by 8, so that'll become, well, negative. So 8 times 2 is 16y. And then 8 times 1. But now keep in mind, there's that negative. It's applied to the whole thing right here. So that's negative 8. So what happens here? Collect the like terms like we did earlier. So still the same bottom, 24. 24 and 16. If I'm not mistaken, that is 8. So that becomes 8y. Now over here, negative 9, negative 8, more of a negative. So that's negative 17. Now, can we take any like terms away? To my understanding, I don't see anything like here. 17 is a prime number, so right off the back, I know there is nothing alike. So moving on down to the next page, 441, we're going to be dealing still with this whole fact of understanding. Well, page 441. Class example 3. Oh, my apologies. 4 we're dealing with now. We're doing simplification. So first things first, we're dealing with a, and that is 7x plus 3 over 2 plus 3x. Okay, looking at that, you're going to be realizing what happens in this case is that, well, 3x, where's the fraction to that? It's confusing probably people right off the back. So what you need to understand is that this is over 1, but it's not shown. You have to understand it doesn't have to be shown to actually understand that. So with that in place, what's going to happen then is that this is over 1, this is 2, so the lowest common denominator is 2. So now from here, you leave that alone, so you just rewrite it, 7x plus 3. Now times that by 2, you get 6x. Now collect the like terms. Okay, what's going to happen here? 7x and 6x. We have 13x plus 3 over 2. You can't do anything else because the 3 is a prime number. 4a is done. Let's move on to the next one. No need to find an NPV for that one because of the fact, once again, NPVs only deal with denominators. If there is no variable in the denominator, there is no NPV, or restrictions, as like some people like to call them too. It's just restrictions is where you have to include the variable then, if you do that. So moving on to the next one, we are dealing with B now, where it states 4 minus y minus 4 over 9. Just like I was saying earlier, anytime you have any problems dealing with this whole fact of a whole number, always make it over 1. So now the question is, if this is over 1, this is 9, what do you have to do over here to make the lowest common denominator? Times it by 9. So what ends up happening is that this whole thing is over 9. I had to times this by 9. 4 times 9 is 36. Minus 4. Be careful. This negative means it's applied here and here. For my apologies, that's negative y. And then that'd be positive 4. Okay, collect any like terms. 36 plus 4 makes the 40 minus y over 9. There's nothing else more you can do from there. Okay, that's class example 4. Let's move on to class example 5 now, where we're going to be dealing with adding subtraction with common variable denominators. So in that case, now we're going to introduce this whole fact of having NPVs involved. So if we have NPVs, we're going to have to basically deal with NPVs. 441, example 5. A 2 over x plus 7 over x minus 1 over x. Simplify, express answers, lowest terms, and indicate non-permissible values as restrictions on the variable. So that's what they basically want us to do here. So in that case, my board. There we go. Okay, so with that, in fact, they're all same common denominator here, so you can just make one big X there. 2 plus 7 minus 1. That's the only thing you're doing here. So in that case, 2 plus 7 is 9, minus 1 is 8 over X is your answer. And then your restriction, look at the NPV, because 0 is X cannot be equal to 0 right off the back. And you want to state that. B. 5b, now we have 5a plus 3 over 2a plus a minus 6 over 2a. Same thing like earlier, same common denominator here, so just deal with the top here. So 2a, 5a plus 3, I'm just rewriting exactly what it says, plus a minus 6. Collect the like terms, 5a and a. What do you get when you get those? Well, you basically gonna get the whole fact of a, so that becomes 6a. 3 and minus 6 becomes a negative answer over 2a. Now, you're not done. In this case, there is something alike, the 6 and the 3. So anytime that happens, what happens over here is, well, 6 and 3 is common with a 3. Open the bracket up like we've done in the past. We're factoring here. So that's going to happen is that you have to times this by 2a minus 1 over 2a. Now here you ask yourself, can we do anything with the 3 and the 2a below? Well, yes, you can actually. What you can do is take, oh, actually you cannot, because unfortunately this is not, that's a prime number, and that's not in the 2 times table, so you can't do that. But you can look at the 2a and give me the restriction. So a cannot be 0. So that leaves us with the fact of this is our final solution. Okay, for 5c. There we go, 5c. 3y minus 1 over 3y minus 1 over 3y minus 1. So in this case, what you're doing is that both the common denominator, don't have to do anything to the top. Just collect the like terms, 3y minus 1. Well, you know what's going to happen here? The top and the bottom are exactly the same. But before you cross out anything, always list the NPVs. So right here is the NPV. 3y minus 1 cannot equal to 0, plus 1 on both sides. 3y cannot be equal to 1. Divide by 3, divide by 3. There's your NPV, 1 over 3. So our final answer, when we cross that out, we're going to have basically, cross out, you're going to have 1, comma, cannot, y cannot be 1 over 3. That's basically our final solution for that one. Now, so this subtraction, that 4x plus 10, class example 6. So we have 4x plus 10 over x plus 3 minus 2x plus 4 over x plus 3. So they told us that it reduces to 2, and it gives us an NPV in their case of x cannot equal to -3. So let's see if this is true. So first things first, this is there, so collect the like terms by first putting the same common denominator. Next, rewrite it, 4x plus 10. Be careful, negative sign means this is negative and that's negative. So minus 2x minus 4. Now collect the like terms. Now like what we did earlier, the 4x is alike, the negative 2x is alike. So that will give us, well, 4 minus 2. That should give us 2x. 10 minus 4, well, that's positive 6 all over x plus 3. Well, the next step is what's common between the 2x and the 6. There is something common. The commonality is this 2. So x plus 3 over x plus 3. Don't cross out anything yet. What you need to first do is list the NPV. The NPV is found from here or here, both the same anyways. X cannot equal to, well, 3, -3 I should say. So that leaves us with this crossing out, that crossing out, and 2 is our answer. So that is true. They were right to say that. That's class example 6. That leaves us with one more here, if I'm not mistaken, from page 442 now, which is dealing with simplifying, express answers, lowest terms, and so forth. So now the next part is dealing with the same thing that we did earlier, but now we need to find the common denominator, which we didn't have to in these previous ones because they already gave us the common denominator with all the rational expressions. So 442 now we're on. 442, class example 7. Okay, A, 5 over 3p plus, well, that leaves us with 2 over 7p. Okay, so both of those are different denominators. So what we need to do is 21p would be the common denominator here. So now you need to ask yourself, how do you go from 3p to 21p? Well, first things first, what you need to do is multiply by, well, 3 times what? 7. So 5 would be the one that you multiply on top. But at the same time, so why don't I just rewrite it? So 7 and times by 5 plus, what do you have to do from here to go to here? You times by 3. So 2 times 3. Okay, now you can simplify that by going on by actually showing 7 times 5 is 35 plus 2 times 3, which is 6, over 21p. Now, can we do anything else from there? Nothing's, oh, well, yeah, 35 plus 6, which is 41 over 21p. 41, I believe, does not go into nicely to any number. So 41 over 21p. One more step, restriction. What is the restriction for this? Well, looking at 21p. So because there's nothing else associated, just 21 with the p cannot be equal to 0. There is our final solution for that one. 7b. 7b says the following. 1 over 3y plus 6 over 5. Okay, so in this case, what's going to happen is that the common denominator is basically, if you multiply this and this together, is going to become the common denominator. Kind of like very similar to what we did over there, but we didn't have to include the p squared part. So what's going to happen is that 15y. So now from here, how did I go from 3y to 15y? I times it by 5. And that'll be 5. Now over here, though, I had to times this by 3y. So 6 times 3y, which is 18y. Now collect anything that's common. There is nothing else in common. You can't cross anything out. So we just have to state the NPV now, comma. 0 is again the NPV. That leaves me to the next one. And that's C, 2x minus 5 over 6x minus 3x minus 2 over 3x. So first things first, you got to ask yourself once again, well, what is common between 6x and 3x? So if LLCD for that one, well, 18x would be the most common. So that means 6x, I had to times it by 3. So in that case, actually 12x, 6 times 2, 3 times 4. That would be a more appropriate LCD. So 6 times x, so I have to times this by 12x. So times this by 2. I'm going to rewrite everything with a 2 in front and then put everything out right after. Makes it easier for me to know what's going on. And now there's a subtract sign. Be careful with that subtraction sign because that applies to everything. So what did you have to do this? By times by 4. So literally put the 4 with the 3x minus 2. So that'll make it easier when you want to collect them. Okay, that means 2, FOIL that, or use the distributive property as the correct terminology for that is 4x minus 10 minus 12x plus 8 all over 12x. Okay, now collect any like terms. Here's a like, here's a like. How many now do we have? We want to get less of a negative number in that case. We get negative 8x, negative 10 plus 8, negative 10 plus 8, a little bit less of a negative number, all over 12x. Now in this case, the numerator has something that's common, negative 2. So do the deed by taking it out, negative 2, open up that bracket, that becomes 4x plus 1 actually, all over 12x. Okay, are we done? Not just yet, because you could simplify that the 2 and the 12. In this case, NPV will still be 0, so I'm not going to worry too much of not worrying about canceling out just yet. So that will give us negative 4x plus 1 all over 6x. Oh, don't forget the NPV. X cannot be 0. There we go. So this is the last question, 7D, and it's a class example where you have to find the common denominator of 2a squared and 5a, and that would be 10a squared. So what ends up happening is that there's the 2a squared and there's the 2a, then we multiply with the 5a, the 5, then we multiply the 2a. Keep in mind you have to do the top and the bottom. These are multiplication signs, don't get confused. If you do that, you're going to actually just distribute them now. You get the 10a squared and 10a squared. Excellent, you have the common denominator now. The next thing you need to focus on is, well, the top.
Do it correctly by timesing by 5. 5 times a, 7 times 5, 3 times 2a, hence the fact that's where they are. So that brings us to the next part is collect like terms with the 5a and the 6a. Keep in mind, negative 6a is greater, so you're going to have negative 6a plus 35 over 10a squared. Can you simplify it from there? Well, unfortunately, you cannot. I just rearranged the a to the right, and that's all in a nutshell.